Alright, so we want to find out everything about this graph. You're going to use the first derivative to find both increase and decrease and maxes and mins. So we'll take our first derivative. F prime of x is just going to be 12 plus 3x squared. And the critical points are where this guy equals 0, so what you're going to do is factor him, take out a 3, 4, oops, that was supposed to be a minus, my bad, 4 minus x squared, so that's 3 times 2 plus x times 2 minus x, so this equals 0 when x is either a minus 2 or a positive 2. So if we put these on a sign line, the only place your derivative is 0 is negative 2 and 2, so that's the only places it can go from increasing to decreasing or vice versa. If I put in any number greater than 2 into my derivative, the easiest one to put into is this nice factored form. So if I put in anything greater than 2, like 100, 3 is always positive, 2 plus 100 is positive, 2 minus 100 is negative, so positive times a negative will be a negative, so I'm going down in this region. If you plug in anything between negative 2 and 2, like a 0, positive, 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 up. And then if you plugged in anything over here, it goes down. It tends to alternate unless one of these things is to an even power. And so now that you've got this graph, you can tell that it's going to have, since it goes down and up, that this guy here is a minimum when x is negative 2 and a max when x is 2. To actually find the min and max values, the actual point on your graph, they want the y values. So this pen is dying, so we'll try another one. So we'll do f of negative 2, and you plug it all the way back into the original, is 5 plus 12 times negative 2 minus negative 2 cubed. And if you do that, you get negative 11, and f of 2 is 5 plus 12 times 2 minus 2 cubed is 21. So what we can say is that we have a minimum value of negative 11 when x is negative 2 and a max value of 21 when x is 2. So 2 nice points on our graph. When we go to graph it, we'll have that, 2 and 21. So now you kind of have the basic shape, decreasing, increasing, decreasing. And if you kind of want to flesh it out, you can find some concavity. So to find concavity and therefore inflection points, you're going to take the second derivative. So we're going to do the same exact process with the second derivative. So f double prime is that. We kind of want to find where it equals 0, so we factor him. Whoops. Whoops, I was supposed to take the second derivative of that guy there. That's the first derivative again. So second derivative, taking the derivative of this, that's just negative 6x. This will only equal 0 when x is 0. So sometimes I put it right on here. And if I plug it in anything less than 0 into here, negative times a negative will be positive. So it's concave up before 0, and then if I plug in anything greater than 0, negative 6 times something greater than 0 will be negative, so it's concave down beyond 0. And so now you've kind of got, that's basically your graph sitting there, and you have a nice inflection point when x is 0. So your inflection point when x is 0, the y, the very original function, is a 5. So when you go to graph, you've got all this lovely stuff. We have a minimum at negative 2, negative 11, a max at 2, 21, an inflection point at 0, 5, and you just connect your dots, la la la, you get something like that.